Hi, in this video we will turn this Python function into an HTTP service using the Cloud Development Kit, which is also called CDK for short. CDK is a tool for scripting infrastructure such as deployment images, databases, and proxy servers. The output of CDK is a CloudFormation template, which is generated by calling CDK synth and can be directly deployed to the cloud using the Management Console or CLI. As you can see, this function performs its work by reading data from DynamoDB, so we will need to make sure that not only we have an HTTP endpoint for this, but we also give grants for accessing the user's table in DynamoDB. Let's start typing. We will use the console to create a new empty folder which is necessary for CDK to operate in. I will call this folder Python HTTP. And let's go into this folder and initialize the CDK project, which is done by CDK init. We have to specify the language we would like to use for building our stack. I will use Python for this video. Now we can take a look at our newly generated files. It's in the Python P HTTP folder. Let's delete the tests because they are not relevant for this video, and add all the other files to the repository so that they become a friendly green color. And as you can see, there's a readme MD which basically guides us through the process of setting up this stack. So first we will need to run this command to create a virtual environment. Once this is done, we have to activate it. And the next step is installing the requirements. Now in this particular example, we will use a latest version of the API gateway integrations, which is alpha, and therefore we have to import it explicitly. It is called AWS API Gateway version 2 alpha, and the integrations module of this integration is alpha. Good. Now we are ready to run the installing of the requirements. And the next step is setting up the interpreter to use our environment. As you can see, when we go into our API, there is no interpreter configured. Let's configure it now. We are going to use a new interpreter from the existing virtual environment that we have just created with the command line. It's already on the right path. You need to select the Python executable and press OK. And after this, and when the indexing finishes, everything turns green and we can continue developing our stack. A stack is really just a synonym for an application in the lingo of AWS. So this is our application, and you have to specify the account and the region. I leave it as is for this example. Of course, you would have to swap in your real numbers here. We can go ahead and build the stack itself, which is in this other file. And as the comment says, this is where our stack goes. Now, since we would like to access a DynamoDB table, we would need to get that into the stack. We are not going to define it here, but just reference it. It is called importing, and we can do that by using the ARN of tables. To be able to use that later in this CDK stack, we would need to add a reference. I will put that code into a separate class, imported resources, of which the constructor will receive the stack, which is going to be our stack, the application itself. And here we define the users table field, which is going to be a DynamoDB construct. So we need to import that module, AWS DynamoDB table from table ARN. And here, first we have to pass the stack, give this object a name. This is the users table, and then the ARN itself, which is, I will use a prefix because if there is multiple tables that you would like to import from the same account and region, this is a simple and convenient way to do that. ARN is Amazon resource name, so it's no magic. It looks like this: ARN colon AWS colon Dynamo DB. We have to then specify the region and then the account, and we are looking for the table object, and now we are ready with the import. So we can get a reference to this imported resource by creating a new variable. It can be a variable, it doesn't need to be a field. Pass self, which is the stack itself, and now we can create the Lambda function. I will put that code yet into another class. It's going to be the user lambdas class, and the init method here also is going to get the stack, which is the application again, and the resources, which is imported resources. Now we can go ahead and create a get user field, which is going to be a Lambda function. We have to import the lambdas first, and AWS Lambda function. This is going to be a function, and we can pass all the parameters. Lambdas have quite many parameters. We will pass in the more meaningful ones. We have to pass the name and the stack, of course, and then comes the name parameters. So function name, let's call this get user in the name column as well. The handler is really the name of the function to call when this function is called, which is going to have to be fully qualified in terms of module name. So get user dot the name of that function. Quite simply, there is one more interesting one, the memory setting, which is expressed in megabytes. 512 is a sweet spot for the current Lambda executors. And there are still more. You can specify a timeout here, which is defined as an instance of the duration class. You can set this up to some arbitrary seconds. Let's use 10. The default would be 3. And let's also do some magic. If you have many default parameters, for example, you have several lambdas in the same folder or same repository, you can create common parameters by just creating a dictionary, lambda defaults, and list all the defaults that you would like to have here. So first, let's say this project only ever uses Python as the runtime. So let's pick the latest Python environment, and also it is the same repository, so the code is going to be the same for all of them. Code from a set, it's really just a name of the folder, it's in the src folder. And some sweetness, the architecture. Lately you can define to use ARM servers for Lambda execution, which are cheaper and faster than the Intel ones. So now that you have the defaults, you can pass them into the Lambda definition. And of course, we were saying that we need to grant permissions for this Lambda to access Dynamo. And so this is why we are passing in the resources in the first place. So the users table, we need to grant read data to our get user Lambda function. So grants are set, the Lambda definition is also set. All that is left is of course calling this code, which is user lambdas. It gets the stack and the resources, and now we can create the API itself, which is the proxy mapping. It's a little bit long, so let's create it in a separate function. Create user API, and for this we will pass in the lambdas. This is going to be a function that gets the lambdas and creates the API. Now, user API is going to be coming from the API gateway, and we have yet to import that. AWS API gateway. Let's just give this a more friendly name and also get the integrations. And now we can define our API. This is going to be an HTTP API. It is going to get the stack, which is self in this case, user API, which is the name, and we will need to specify one more name parameter because by default this API will exist on the execute API AWS domain, and you are highly likely not to call it from there, from any browser. For this reason, we need to make sure that this can be called from different domains, and that is specified by the cross-specified parameter, which is a dictionary of things that you would like to allow. So allow methods, because this is the API level, we will not be restrictive here. API gateway CORS method any. We will restrict this and the individual route level. We also are going to allow origins. We have to. This is a list of domains. We will allow anything again. And the last one is the headers, which is yet another list. And let me list some useful things here. The content type is a common one. If you want to have authorization, you would need to list that here too. If you would like to use this from AWS authorization programs, such as with signature 4, you would have to pass these XAMZ headers as well. And of course, depending on your exact need, the list may vary. It might be longer or shorter. This is a reasonable default set of headers to pass for generic use. And the user agent is going to be the last. Okay, now we are ready with the API. We can add paths to it. So user API.add route. The path is going to be /user. The methods, this is where we restrict the methods, is going to be HTTP method get. So we just want to allow get for this particular path. And the last one is the integration, which is going to be an API integrations, Lambda integration, for which we only need to specify a name and the Lambda itself. And we are all set with the definition. The next thing is to verify that we are done, and we can do that by calling CDK synth and just see the template for ourselves. So CDK synth, I also pipe it to more. Apparently there's a typo. This needs to be a list of allowed methods. And here we go. This is our CloudFormation template. As you can see, all the things that we have defined are showing up here. First, the permissions to DynamoDB, then the Lambda function with all the settings of architectures and memory sizes, and last but not least, the API itself with the extra headers and the path. So this is it. Thank you very much for watching, and see you in the next one.